Let's start on our third big foundational piece. What you should have ready going into OChem 1 on day 1. And it is the determination of formal charge. And most likely you did this in Gen Chem at some point. You learned how to determine formal charge in Gen Chem. The reason why it's important here, so let's revisit our true north statement, okay? Our true north statement, what organic chemistry is all about. Remember, organic chemistry is about the movement of electrons from high density to low density, okay? So since this class is about the movement of electrons, you need to know where your electrons are. That is one of the big skills in this class, and it's an underrated skill. You need to know where your electrons are. And what formal charge allows you to do is formal charge allows you to determine those areas of high electron density and low electron density, because this class is about the movement of electrons from high density to low density. And so remember, high density electron centers are usually negative, or just have a lot of electrons. Low density are usually positive and have less electrons. Okay, and so one major place where I differ from how formal charge is usually taught is the formal charge formula that you're usually given by professors is just really wordy and dumb, and has it overcomplicates it. The way I like to view it is formal charge is equal to the number of valence electrons that whatever element that you have has. The way that you find the number of valence electrons is always on the periodic table. And then you subtract the number of dots and lines that are surrounding that atom. Okay, that's not super scientific. Dots are electrons, lines are bonds. I just like making it super simple. Dots and lines. Okay, you don't have to do anything like 1/2 or the number of bonding. Who cares? Okay, valence electrons minus dots plus lines. And so what I did here was give you a little mini periodic table, all right, of the elements that you care about in organic chemistry, just to remind you that hydrogen has a valence of 1, boron and aluminum have a valence of 3, carbon has a valence of 4, nitrogen 5, nitrogen, phosphorus, oxygen, and sulfur 6, and all the halogens have a valence of 7. So what I'm going to have you do is I'm going to have you try it out. What I want you to do is figure out the formal charge for this nitrogen right here. So use the formula, okay? I'm gonna guide you through this one. So formal charge is going to be equal to the valence. So nitrogen has a valence of 5 always, okay? That's from the periodic table. And surrounding it, we have 4 dots. So 4 plus 2 lines. That's it. Around that nitrogen, we have 4 dots and 2 lines. So the formal charge of this nitrogen is 5 minus 6, which equals -1. And the way that we express that is just the negative sign by the nitrogen. And so what you know just by looking at this is a center of high electron density. That is why we do formal charge. It helps you know where there are charges and where your centers of high electron density and low electron density are. So what I'm going to have you do is I'm going to have you dive into this. I want you to find the formal charge of all atoms that are not carbon. So anything that is not carbon on these structures, I want you to calculate the formal charge for them. Okay? That's all I want you to do. So I'm going to have you venture boldly into this. Give this a shot. Pause your video, and I will see you in just a sec, and we will review all of it. All right, let's dive in. So for chlorine here, chlorine has a valence of 7. it is surrounded by 6 dots and 1 line. So that's 7 minus 7. This chlorine has a formal charge of 0. If the formal charge is 0, you don't have to write anything next to it. Okay, and notice that all of these chlorines have the same formal charge. All of them have a formal charge of 0, so we don't have to write anything. Aluminum here. Aluminum has a valence of 3, and there are 0 dots surrounding it and 3 lines. So aluminum also has a formal charge of 0. So this structure right here, you could have just expressed it the exact same way. Let's move on to sulfur right here, okay? So sulfur has a valence of 6 minus 4 dots and 2 lines. 6 minus 6 is also 0. We don't have to express anything. What I want you to notice here, this hydrogen that's drawn in, let's calculate the formal charge. Hydrogen has a valence of 1. It is surrounded by 0 dots and 1 line. So this also has a formal charge of 0. Okay, if you see a hydrogen that is only bonded once, its formal charge is always going to be equal to 0. So let's start cruising on these, okay? So this oxygen right here, now that you know how to do the formula, check your work against mine. This oxygen up here has a formal charge of 0 because it's 6 minus 4 dots and 2 lines. Okay, double bonds. That is 2 lines right there. Same with this oxygen right here. This oxygen is also 0. Okay? This oxygen in the structure right here, it's 6 minus 6 dots and 1 line, so 6 minus 7. That has a formal charge of -1. So the way that we express that is just a negative sign right there. Nitrogen over here. So I'm going to start rolling through these now, okay? I trust that you know how to do the formula. This nitrogen right here should have a formal charge of +1. Valence of 5 minus 4 lines. This oxygen right here on this next structure has a formal charge of +1. The oxygens here and here have formal charges of 0, so I'm not going to write anything now. And this one has a formal charge of -1, so we're going to do just a negative sign there. Ooh, I forgot to draw in dots on this one, so there should be dots right here. So pardon me. On this one, if you got very funky answers, we are going to amend them. And so that's actually instructive. You are usually not going to see formal charges that are higher than +2 or -2. +2 and -2 are really, really rare to begin with. Most of the time, you are going to see formal charges at the extreme of -1 and +1. It is extremely rare for you to see anything bigger. +2 and -2 are the far, far reaches, and they're about as rare as the Easter Bunny in this class. Just keep that in mind. If you're seeing formal charges of +2 and -2, that should send off alarm bells. So you probably got something really funky if you did these oxygens here. That was my bad. I should have drawn in electrons, but this is instructive. Now you know. So these oxygens right here with the electrons in should have a formal charge of 0. Same with this nitrogen right here. This bromine right here, valence of 7 minus 8 dots, no lines. This bromine has a negative formal charge. This bromine in the next structure has a 0 formal charge. This oxygen in the next structure also has a 0 formal charge. This sulfur right here has a -1 formal charge. And what I want you to notice is oxygen and sulfur kind of act the same way because they have the same valence. So that's a pattern that I'm kind of cluing you in on. You are going to be able to assimilate these patterns a little bit later on as you get better with this, but let's keep rolling. Aluminum right here should have a -1 formal charge. All the hydrogens, since they only have one bond, have a 0 formal charge. Phosphorus right here has a 0 formal charge. It acts the same as nitrogen. Oxygen right here has 2 dots, 3 lines, valence of 6. So 6 minus 5 gives us a +1. Oxygen here, -1. Chlorine on this structure has 0 formal charge. Nitrogen here has 0. Nitrogen on this next one, -1. Um, Nitrogen here, what I hope you did was 0 because it's a valence of 5 minus 2 dots and those 3 lines of the triple bond. Then oxygen right here will have a positive formal charge. And then for this last one, everything has a 0 formal charge. What I want you to notice is sulfur right here. Even if it looked a little weird to you, sulfur has way more than an octet. Right here, it has 12 electrons surrounding it. That is okay. Anything that is phosphorus or sulfur or bigger can have an expanded octet. That's something from Gen Chem that you can just tuck away there. So that's it. You now know how to do formal charge. It really and truly is just knowing how to do this formula right here. So tuck that formula away. But I'm guessing after doing all of these, you probably know that formula by heart after all of the tedious work here. You now know formal charge. You, looking at these, could be able to identify the high density electron centers and the low density electron centers. And that's a big deal because that is going to be huge later on in the class. And that's it. In the next video, we are going to talk about hidden electrons, which I think is the most important foundational skill going into your first day or week of class. I will see you there.